Talked about in section 1 how we were evaluating functions. If I had some function, f of x equal x squared minus x plus 2, and we're finding some functional value, then we would just substitute that value in for all our occurrences of x, or whatever that variable was, and then we would simplify that to get our function value. Recall we said the input was the x value, that is our 2 in this case, and our output is the functional value, which on a graph was y, but in this case it's just the output of 4. So with 2 as the input, the 4 is the output. So another type of function we'll have to use when we're doing this is what is called a piecewise function. So a piecewise function, it is a function that is defined as different expressions for different values of x. So if I look at an example, we usually have a function equal to several parts. I could do a simple one like x minus 1 and x plus 2. So these are two different types of functions, two different types of linear functions. So what I usually do is I put a condition on their x. Maybe I say x greater than 1. This means if my input is greater than 1, then I would substitute it into this piece. And then maybe this one is x less than or equal to 1. And then maybe less than or equal to 1, greater than or equal to 0, something like that. So if my input, if my x is in this range, I'd plug it into this piece. And if it's in neither of those ranges, then it does not exist. So when you're evaluating piecewise functions, just remember you're going to plug the input into the piece that contains that input. So if we look at this first example, we have f of x equal to x when x is less than 0 and x squared when x is greater than or equal to 0. So if we look at this, so we have the inputs for the first piece are when x's are less than 0, and for the second piece, we'll just call this piece 1, we'll call this piece 2. This is for inputs that are greater than or equal to 0. So your inputs are always what comes in the second column, and then you would plug them into the expressions in the first column. So if I'm looking for this first problem, it says, what is f of 2? So my input is x equal 2. So we have to determine, is 2 less than 0 or is 2 greater than or equal to 0? It is obviously greater than or equal to 0, so it's going to go in piece 2. So when I'm trying to find f of 2 for this piecewise function, I'm plugging it into piece 2. Piece 2 says take x squared, so 2 squared is 4. All right, secondly, we says what is the value of f of 0? So f of 0 is 0 less than 0, or is it greater than or equal to 0? The big idea is since it has the equality on the second piece, it's going to go in piece 2 again. Because wherever the equality is, that is where it's going to be. It should not be on both pieces, because if you have equality on both of them, then you do not have a function. So f of 0 is simply going to be 0 squared, which is 0. Finally, for the last one on this problem, it says what is the value of f of negative 3? Well, negative 3 is definitely less than 0, so for this one, it's going to go into piece 1. Now, piece 1, it says f of negative 3, I'm going to plug it just in for x. Well, if you just plug in x for x, it just becomes whatever the x was. So in this case, negative 3. Let's look at another example. So this is a piecewise function that has 3 pieces. So we have x minus 2 when x is less than 0. It's just 5 when x is equal to 0, and 3 minus 2x when x is greater than 0. So we'll call this piece 1, piece 2, and piece 3. Now piece 2 is pretty boring because it's valid only for one input, and the rest are obviously valid for quite a few others. So this says what is f of 0? Well, 0 is obviously 0, so that's going to go in piece 2. And it says if x is equal to 0, the expression is just 5, so it's automatically 5. So f of 0 is 5 for this function. F of negative 3, now negative 3 for the input, negative 3 is less than 0, so that's going to go in piece 1. So if I plug into piece 1, it says x minus 2, so that's negative 3 minus 2. Negative 3 minus 2 is negative 5. Finally, we have what is the value of f of 4. So 4 is definitely in piece 3 because it is bigger than 0. So if we want to do that, we're going to plug in to our piece 3. So f of 4 is going to be 3 minus 2 times 4. And then we just evaluate that expression. 3 minus 8 equals negative 5. Now, ironically, these had the same function values if you look at f of negative 3 and f of 4. That's just a coincidence. There is no real reason for that. It just happens to be the same value. So finally, this is kind of a different question. This says, is there an x value where f of x equals 0? Well, so now this is a little different. We're trying to figure out, is there some point where x equals, or where y equals 0, where our output is equal to 0? So if you look at these three expressions, there are three pieces we have to check. So piece 1, if you look at piece 1, it was simply x minus 2. And then piece 2 was just the number 5, and piece 3 was just 3 minus 2x. So if I want to know if this is ever 0, for piece 1 it says it's 0 at x equal 2. But there is a problem. If you go up to piece 1, if you recall, that was only good for x less than 0. 2 is not less than 0, so even though that function, x minus 2, would eventually have a y of 0, it's not at an x that actually works. 5 also does not work. That's kind of ludicrous because 5 is never 0. Finally, let's look at piece 3. So if we want to know, is piece 3, could this ever give us an output of 0? Well, I can solve this by subtracting 3 and then dividing by negative 2. So that would, at x equal 3 halves. And piece 3 is okay because if you recall what piece 3 was valid when x is greater than 0 and 3 halves is greater than 0. So the only x, the only input that would give us 0 is 3 halves because f of 3 halves would get plugged in to the third piece, which is going to be 3 minus 2 times 3 over 2, which gives us 0. So if you have a given input, you can find the output, or if you have an output, a little different in piecewise because you have to figure out which piece it is, but we can very simply figure out what that value is. Finally, like we did last time, we can also use piecewise functions graphs to figure out some values. Now, a graph of a piecewise is a little different because it's got multiple types of graphs pieces. So you might have something that has a line, and then maybe it stops here. If you recall from algebra, an open circle means not included, a closed circle means included. So maybe it's kind of going down this way, and then it jumps up to this point, and then maybe it's flat for a little bit. Maybe it stops there, goes down here, makes some kind of curve. But this would be some kind of graph of a piecewise function where you have lots of different types of things happening. So if you recall, we have our x and our f of x, and remember f of x is the output, but for a graph, the output is generally y. So on this graph, we're generally thinking of these points as x, f of x, instead of x, y. But again, those will represent the same thing for their outputs. So here is a piecewise function, kind of an interesting one. So it has a closed circle here. So we know it's going to start here, and that looks to be at negative 4, 7. It's going to go down here until we get to an open circle. So that means we're going to get really, really close to that, but not touch it. Jumped up to this singular point here, comes down here to the open circle, then kind of continues but stops here. So this one does not go on forever. So if you look at f of negative 1, okay, so f of negative 1 means it has an x of negative 1. So if x is negative 1, this is where we have a couple choices. On our graph, this has an x of negative 1, this has an x of negative 1, and this has an x of negative 1. But since two of those are open circles, we will not use those values. Those are going to be just kind of values where it gets close to but doesn't touch. So we look for a closed circle at negative 1, and that appears to be at a y of 1. So an x of negative 1, the functional value, the y value is at 1. Now if we look at f of negative 4, same idea. Our input is negative 4. So if we go to negative 4 and kind of go up here, you can see that's at this closed circle here. It's at the very end. So we just look at what the y value is. It appears to be 7. So f of negative 4 is 7. F of 2, same idea. F of 2, we're going to go to 2. It looks like, I don't know, I'm going to say it's somewhere around there. So if x is equal to 2 in this case, it looks like the y is 3. So f of 2 is 3. Finally, f of 6, if you look at the function when x equals 6, 6 is here, I can go up and down, and you see I do not see any graph. This graph actually stops at x equals 3. So this one we would say does not exist because there is no y value for x equals 6 because there's no graph when x equals 6. All right, let's look at some other problems here that is kind of going backwards. What if you have the output and you want the input? So what are we going to do for that? All right, so this first one says what happens when f of x equals 0. So again, the output of 0. So graphically, when y is 0, what are our x values? So if I look on this graph, the 2 points that appear to have a y of 0 are these 2 points. So that appears to be an x of 1 and an x of, it looks a little past negative 2, hard to say. We'll say negative 2.25, something like that. All right, secondly, it says if f of x is equal to 6, what is the x value? So we're talking about a y equals 6. So if we come up here, I believe this point here has an x of 6, or a y of 6, pardon me. And this point has a y of 6. So all we have to do is just simply state what those x values are. And that appears to be 3 and negative 4. Finally, this looks like the same problem. So we're going to turn this to negative 6. If f of x equals negative 6, what is the x value? So if you go down here to negative 6, which is here, the only point that appears to have a y value of negative 6 is this open circle. But remember, we said open circles are not included. So since there is no closed circle with a y of negative 6, we would just say none exists. It does not exist. So the biggest thing with piecewise functions is making sure that you are plugging into the right piece. And we'll certainly look at some applications in class of where we can use these piecewise functions and how you can use them.